CO2 emission, or oxygen emissions from a plant, and CO2 uptake. So you can measure that.
Yeah. No, just do the time at the top, and then how much it either decreased or increased.
So tell me here, so you have your time here, and then I'm confused as what's gonna go in the box and what's gonna be on this side.
This would be the certain CO2 or oxygen, or like, this would be the gases on the other side.
Okay. And then what are you gonna be doing? What is your experimental setup? Is there just one plant, or?
It would probably be, oh yeah, okay, so it would be different.
Oh, good, that's good.
So, it would probably still have the time, like CO2 and O2. So this would be like for one plant and two plant. And then between all the CO2s, there would be like an average, I guess, or an average percentage probably change, percentage of change,
Okay.
and then percentage of change, and then maybe comparing all the percentages of change between all the plants.
And changing from what to what?
Either decreasing or increasing
Okay, for each of the things?
for each, yeah, each of this.
What do you expect to see as one changes? Do you expect to see a change in the other, or are they independent?
This should be inversed. This one should like decrease and that one should increase.
Okay.
But just like comparing the slight differences.
So are these, we're getting to like, now, data and trials. So these are three different plants you have here. How are you treating each of these plants? Are you doing,
Oh,
what
you
kind of-
mean like one control? Yeah,
Sure.
Sure. And so maybe like the amount of sun, so the light, and then maybe an increased light to this one,
okay,
and this one has like no light.
okay.
Just so the variable would be light.
And given that you have kind of all resources at your disposal, how many plants do you need in this condition to feel like you have a good enough data set to compare to the other conditions?
Probably 3 or 4.
Okay.
3 or 4 in each.
Why wouldn't you want just one? Or would you want?
I probably wouldn't want one because it could be. It wouldn't be like statistically significant.
Okay. Let's see, I want you to take this information now, and on another sheet of paper, I want you to draw out your experimental setup that could generate this data that you talked about. And we can just, for this machine that's measuring it, you can just draw a box or something,
Yeah.
something generic.
So within each, so this would be no light, and I guess that this would be low light. This would be high or intense light, and so we'd have 1, 4. With some, and then like
This thing, yeah,
This
perfect,
thing, yeah.
perfect. It's measuring oxygen and carbon dioxide. And what about these boxes? Is there anything about the condition of those boxes that we need to think about?
probably the temperature
Okay.
of humidity maybe. And I guess water would on all of them. Humidity control.
Would it work to have the kind of boxes that we have here with those vents cut in them?
I feel like it might differ the results
Tell me why you think that.
because the temperature. I mean, the vents are for temperature, but you'd have to like, I don't know. Maybe it would help because it would maybe stabilize the temperature with the amount of light.
Interesting, because you're testing light, not temperature.
Yeah.
What do you think those vents would do to your dependent variable, to the thing you're actually measuring?
I think if we kept the temperature somewhat